Welcome to the Explainer. Let's be honest. If you're learning Go, you've probably stared at your screen and wondered, should I be using new here or make? You are definitely not alone. So today, we are going to finally clear up one of the most common points of confusion for developers new to the Go language.
Here's our game plan. We'll kick things off with the core problem itself. Then we'll introduce new and make one at a time, see what they're all about, and even look at a better alternative in many cases. Then we'll put them head to head. And we'll wrap it all up with a super simple playbook you can use to get it right every single time in your own code.
All right, let's jump right in and tackle this allocation puzzle.
So it all boils down to this one question. Why on earth does Go have two different built-in functions, new and make, just for memory allocation? I mean, they look kind of similar, but they do completely different jobs for very specific types of data. And understanding that difference, well, that's the secret to writing clean and effective Go. Okay, first up to the plate is new. The best way to think about new is as your basic, no frills, just get me a piece of memory tool. It's the most fundamental of the two. So here's the deal with new T. It does two things. First, it carves out just enough memory to hold whatever type T you give it. Second, it fills that memory with zeros. That's it. It doesn't know anything special about the type, it just zeroes it out and then hands you back a pointer to that new memory location. Now you might be thinking, what good is a bunch of zeros? And this is where you start to see the simple elegance of Go's design. This quote from the docs says it all. In Go, tons of types are designed so that their zero value is actually a useful, ready-to-go state. I mean, think about it. You get a zeroed byte-stop buffer? Bam! It's a perfectly good empty buffer you can start writing to. A zeroed sync.mutex? That's an unlocked mutex, ready to do its job. And the really cool part is that this idea stacks. If you have a struct and all of its fields have useful zero values, then the entire struct is useful right out of the box after you call new. But, okay, what if the zero value isn't what you need? What if you want to set things up with some actual data? Well, you could use new and then set every single field one by one, but come on, that's kind of clunky, right? Turns out, Go has a much cleaner, much more expressive way to handle this. Just look at the difference here. On the left, we've got that two-step dance. Call new, then manually set the fields. It works, but it's verbose. Now look at the right. We use what's called a composite literal. It's one clean, readable expression that allocates and initializes all in a single shot. This is way more idiomatic in Go. And check this out. If you use a composite literal but don't specify any fields, like and, file, square bracket, you're just creating a pointer to a zeroed-out file, which means it's doing the exact same thing as new file. This really drives home that composite literals are almost always the way to go. All right, let's bring in our second player, make. And if new is our general-purpose screwdriver, make is like a specialized wrench. It's built for a very specific and very important job. Okay, this is the absolute key difference. Make is picky. It only works for three built-in types: slices, maps, and channels. And unlike new, it doesn't just zero out the memory. It actually initializes the complex, hidden data structures that make these types work. Also notice it gives you back the value itself, type T, not a pointer. Let's peek under the hood at what make actually does for a slice. It's not just grabbing some empty memory. No way. It's doing some serious work. It allocates a hidden backing array, it creates the slice data structure itself, the header, and it sets that header up to point to the array with the right length and capacity. It gives you back a fully functioning, ready-to-use slice. Okay, we've met the contenders. Now it's time for the main event. Let's put new and make side by side to make the differences totally 100% crystal clear. Honestly, if you remember just one thing from this whole explainer, make it this table. New is the generalist. It works on any type, it just zeroes the memory, and it gives you back a pointer. Make is the specialist. It only works for slices, maps, and channels. It properly initializes them, and it gives you back the actual value ready to use. Simple as that. And this code says it all. I mean, look at that first example. You could technically use new to get a pointer to a slice variable, then use make to initialize what that pointer points to. But why would you? It's just painful. The idiomatic Go on the right is so much cleaner, so much more direct. You just use make. End of story. Okay, so let's boil all this down into a simple, actionable playbook that you can start using in your code right now. It really is this simple. Rule 1. If you have a slice, a map, or a channel, you use make every single time. No exceptions. Rule 2.
For almost everything else, especially structs, reach for a composite literal. It's clearer and more powerful. And rule 3, only use new in that rare case when you explicitly just need a pointer to a zeroed out value. And always, always remember, make gives you a value, new gives you a pointer.
And there you have it. You've now got the tools to write much more idiomatic Go. But understanding the what is just the first step. The next level is to start thinking about the consequences of these choices. Using the right tool isn't just about writing correct code, it's also about writing efficient code. Definitely something to chew on for your next project.